Hello, everyone, and welcome to the August Recreational Astronomy Night meeting of the RASC Toronto Centre. My name is Paul Markov, and I will be your host for this evening, coming to you live from Markham, Ontario. We are online this evening due to the closure of the Ontario Science Centre, for those of you who haven't heard. However, our president, Tom Luton, will give us an update on a new meeting location during the announcements at the end of the presentations. Online meetings are made possible by our awesome AV team, comprised of Andrew and Betty Reed, Ward Legros, and Ennio Ciolucci. Regarding future meetings, there is one open slot for the September 4th meeting. We also have open slots for later meetings, which happen on the first Wednesday of each month. If you have a presentation in mind, please get in touch. The speakers for this evening are as follows. Arnold Brody will present The Sky This Month, followed by Peter McMahon, and he'll tell us about what's new at Kitt Peak National Observatory, a Canadian look behind the scenes. And Pavel Krasnovalsky will wrap up the evening's presentations with a presentation called Beware the Red Light. If you're watching us online and have a question for our speakers, please enter it in the YouTube chat box, and Ennio will ask the question on your behalf. If you're watching us online for the first time or not, please let us know where you're from through the chat box. Let's get the meeting started with Arnold and The Sky This Month.
All right. Well, thank you, Paul. And thank you to the AV team of Betty, Andrew, Ward, and Ennio. You guys are awesome. And hello, everyone watching tonight. I'm in Whitby, Ontario. And for the next half hour, I'll talk about what's up in the sky for the rest of August and the first few days of September, up to our next meeting on September 4. Now, this month we have the Milky Way rising like steam from the spout of the teapot in Sagittarius. You can run a mini Messier marathon with 40 Messier objects up in August, and you can do a finest NGC hunt with 11 targets up this month. And we have the Perseid meteor shower, a bright binocular comet, Saturn nearing opposition, a super moon, and an angry sun. There's a lot to cover this month, so let's get started. I like to combine astronomical twilight with night in what I call the observing window, since planets and bright deep space targets can be observed during astronomical twilight. The window is expanding rapidly between tonight and September 3rd, as you can see by the widening of the dark area in the hourglass between those two dates. It's widening quite rapidly. And because of that, the observing window that's currently 7 hours and 20 minutes as of tonight, it will stretch by nearly an hour and a half to 8:48 by the beginning of September. And night also grows almost 6 hours tonight, but over 7.5 by month's end. New moon happened just yesterday. So dark skies with little or no moon interference is with us now for the next week or so. The next dark period starts the last week of August, with new moon on the Labor Day weekend or the day after it. Now, the full moon on the 19th goes by a number of names. The Sturgeon moon, the Cree called it the Flying Up moon because young birds would be old enough come August to jump and fly. The August full moon is also called the Corn moon, or the Ricing moon, the Black Cherries moon, and is also known as the Lightning moon. Okay, let's begin our tour of the night sky with a look at the inner solar system. From Earth's perspective tonight, Venus and Mercury lie on almost the same line of sight. East of the sun, might they be visible after sunset? We'll check that out. Mars, meanwhile, sits almost 64 degrees west of the sun, rising 4 3/4 hours before sunrise. The air is steady before sunrise, so will Mars reveal details under high magnification, or are we still too far away from that little planet? We'll see. Here's how the inner four will move this month. On August 18, Mercury reaches inferior conjunction, passing between the Sun and Earth. And by the start of September, the speedy little planet will reach greatest elongation west of the Sun, easy to spot in the morning sky. Here we see Mercury and Venus 6 minutes after sunset tonight, but with atmosphere disabled, in other words, no daylight showing. And as we expected, Venus and Mercury do appear near each other, just 5.5 degrees apart. Mercury at this moment is just 2 degrees above the horizon. Venus is 3 times higher at 7 degrees 18 minutes above the western horizon. But with daylight restored, Mercury disappears while Venus can still be seen. Venus will appear essentially full at 95% illuminated. You might try using a moon filter to dim the planet down to better discern its limb. And if you have a minus violet filter, you can try that to remove any false colors created by refraction in the thick atmosphere near the horizon. Now, having just emerged from behind the Sun, Venus will orbit further east and be the evening star throughout the rest of this year, reaching greatest elongation east in January. Tomorrow night, Venus's elongation from the Sun is 17 degrees 40 minutes east. But by Labor Day, Venus will have moved 24.75 degrees east, though the ecliptic in the evening flattens and minimizes Venus's climb up the sky. With the Sun at the same depth below the horizon in these different pictures, Venus is only 1 degree higher by the start of September, although 7 degrees further from the Sun. Here's Mercury in the morning on September 3, just 1 day before greatest elongation west. The following morning, Mercury will be at the crest of this roller coaster-shaped orbit. Mercury is 7.75 degrees above the horizon, when the Sun is still 8.5 degrees below. And that's at 6 a.m. So it's going to be very easy to see Mercury during and just after Labor Day. Very easy. But those watching from the southern hemisphere, Mercury will be more challenging to find on September the 3rd. Here's the scene from Argentina. An hour and 15 minutes later, local time, the Sun is 5.8 below the horizon, 5.8 degrees, but Mercury is only 2.5 degrees high, and that's because the ecliptic intersects the horizon at a shallow angle winter mornings in the southern hemisphere. Here's where we can find Mars, rising in Taurus a few hours ahead of the Sun and not far from Jupiter. It will glow around first magnitude depending on its altitude. It is still a small dot, appearing just 6 arcseconds wide. And when we catch up to Mars 6 months from now in January, it will still be fairly small at almost 15 arcseconds. That's because winter oppositions with Mars are poor when the red planet is near its aphelion. Good opportunities are in late summer, and 10 years from now, we finally get one on September the 11th in 2035, when Mars will appear 70% larger, nearly its maximum of 25 arcseconds. At 6 arcseconds now, can details be detected on Mars? Well, maybe, if we can trust the scene from Stellarium. Here we're pushing an 11-inch SCT over 1,000 times magnification. That's like 100 times per inch, and I think 50 per inch is typically the rule of thumb. So I'm not so sure this can be trusted, this scene here. We're probably going to have to wait until the winter time when we get a bit closer to Mars to be able to see some detail on it. Here are the positions of the outer planets along with Earth and Mars as of tomorrow night. From our perspective, Jupiter appears close to Mars, as we already saw. Saturn, meanwhile, appears almost a quarter of the way around the sky from Jupiter. Saturn appears to be around 6 hours ahead of Jupiter in terms of rising, transiting, and setting. Indeed, Saturn transits the meridian at 3:30 later tonight, and Jupiter transits at 9 a.m. That's 5.5 hours later. Uranus should appear near and west of Jupiter. It looks to be around 3 weeks ahead of Jupiter in terms of opposition, and Neptune looks to be around 2 weeks behind Saturn. Well, here are the next opposition dates for the outer planets. Uranus is 3 weeks ahead of Jupiter, just about, and Saturn is 2 weeks ahead of Neptune. As we expected, Uranus is near and to the west of Jupiter this month. That's Mars near Jupiter inside the horns of Taurus the Bull. Jupiter is getting progressively brighter and bigger as we orbit towards the gas giant. It's now -2 in magnitude, though you'll lose a magnitude or so depending on how low it is in your sky. And if you are fortunate to have good eyes, you might be able to pick out the tiny disk of Uranus around magnitude 6. This is how Jupiter will look this weekend with an apparent diameter of 36.2 arc seconds. By month's end, it will grow 6.5% to 38.6 arc seconds. And you might like to try using a light blue or light green filter when observing or sketching Jupiter. These filters will darken the reddish cloud bands and, of course, the great red spot. That will increase their contrast and improve their visibility. There's a fun sequence of events involving the Galilean moons Io and Europa on Friday morning, August the 23rd. The moon Io will cast its shadow on the planet before transiting across itself. While transiting, it will kind of disappear into the brightness of Jupiter. And while that's happening, Europa is going to enter the shadow of Jupiter. The shadow of Jupiter goes off in this direction. Europa will enter it, disappear, and then reappear just before going behind the planet. Here's a video showing you that. Watch now here as the shadow of Io should appear. There it is. You can see it on top of a cloud band. Io has disappeared. Europa is now in the shadow. And as Io reappears, so does Ganymede, Europa, I meant, and it just disappeared. If you may have seen that, I'll show you that again. There's 6 minutes in that circle there. Watch, it's going to be faster than 6, but there's Europa reappearing, and in 6 minutes time, real time, it just disappears. That might be a fun thing to try and catch. Uranus is bright enough to be seen without optical aid on a dark and transparent night. Magnitude 6 is considered the dimmest we can see, and Uranus is brighter at 5.62, although atmospheric extinction will drop it back down to the 6th magnitude range. So I recommend you wait as long as possible. Here we are at 5 o'clock, by which time Uranus is 48 degrees in altitude, and that'll improve your chances of being able to spot it. To help you find it, look for a blue dot a little over 5 degrees southeast of the Pleiades. You can use binoculars to confirm the location of Uranus and then try without. This stellarium scene includes stars down to magnitude 5.6. And there you can see there is a star that's going to help you out, not far from Uranus. You can find Neptune and Saturn rising in the southeast once the sky darkens. Of course, you'll need binoculars or a telescope to spot Neptune. Butterscotch Saturn will shine around magnitude 0.71 or less due to our atmosphere. Now, a few years ago, when Saturn's rings were tilted wide, the dot of Saturn appeared about 3/4 of a magnitude brighter. That's because the rings were tilted wide, adding their bright reflection of sunlight. They're as bright as the planet itself, so that would definitely make the dot appear brighter. When I saw Saturn in the sky with my eye, it did look as though that dot was a little bit dimmer than I'm used to seeing it. And Neptune has the tiniest apparent diameter of all of the planets at just 2.4 arc seconds, but with with sufficient magnification, you can perceive the planet's disk shape and blue color. Saturn's rings currently appear like a line drawn through a circle, imitating a double star symbol in star atlases. It is a very unusual sight, a weird sight in your eyepiece. The ring tilt has narrowed to less than 3 degrees on its way to zero as we pass through the ring plane 8 months from now in next March. Saturn's biggest moon, Titan, is the 8th magnitude dot, sharing the ring plane. And you can try using light yellow or yellow-green filters to improve contrast in the cloud bands and help them stand out. They're so hard to see otherwise. Now, regarding Comet 13P Olbers, it's cruising its way out from the inner solar system, having passed perihelion 38 days ago on June 30. Its high inclination of 44.7 degrees sends it north of the ecliptic plane after perihelion, keeping it above the western horizon after dark for quite a bit of time, around 2 hours. As of yesterday, the comet is glowing at magnitude 7.3. Now, 7.3, that's too dim for naked eye, but easy in binoculars. And here we see its path over the next 4 weeks, each dot representing its nightly progression, and it will cruise by a couple of deep space targets on its way. On August 29, there's a tempting close encounter of comet Olbers with globular clusters NGC 5053 at magnitude 10 and brighter M53 at magnitude 7.6. Olbers should be around magnitude 9 to 10 in late August, similar to 5053, and all three fit comfortably in a wide field of view. A nice low power imaging opportunity. Olbers' orbit doesn't bring it particularly close to Earth with a perigee of nearly 2.5 astronomical units. However, its path high above the ecliptic explains its visibility well above the western horizon after dark for northern observers. And as the comet passes through the plane of the ecliptic, it appears to pass across Mars's orbit. Is that simply superimposed like it is in front of Earth and Venus's orbit, or is it really that close, tight? Well, if we change our perspective, when we tilt this orbital plane a bit, we can watch to see, and sure enough, it does look as though the orbit of Olbers is right up tight against the orbit of Mars. In fact, the two have a separation of 0.3 AU. That's about 10 times the Earth-Moon separation, but it's still quite close. And as a result, there are meteor showers that strike the southern hemisphere of Mars every time it passes that spot in its orbit. Something to keep in mind if you want to build a moon colony, a Mars colony, you're going to probably want to stick to the northern hemisphere. Now, speaking of meteor showers, the Perseids began a few weeks ago in mid-July and runs till mid-August, with its peak occurring on the night of August 11-12, which is this coming Sunday night into Monday morning. The moon, one night shy of first quarter, sets at 11:17 and does not interfere with the peak of the show, when up to 80 or maybe 90 an hour could hit our upper atmosphere. That would be 1 or 2 a minute. Now, while the moon is still up, many astro imagers will aim video cameras at the moon on tracking mounts because the unlit western side of a first quarter moon is also facing the Perseids. And without an atmosphere, the Perseid meteoroids become meteorites in a flash that you can capture. They do hit with the energy of 100 pounds of TNT. They will make a bright flash, and hopefully your video camera frame rate is fast enough to catch it. The parent comet of the Perseids is Swift-Tuttle with a 133-year orbit. last visiting the inner solar system in 1992. Now, here's an all sky view. As we approach midnight, we begin to rotate into the direction of our orbit around the sun, which is that green line you see. Notice how our orbit heads in the direction of Perseids radiant, while at the same time, the radiant climbs towards the zenith, at which point we're plowing headfirst into the debris stream when your chances improve of seeing 1 or 2 meteors a minute. The sun now, at local noon, it descends a considerable 8 degrees and 40 minutes over the next 4 weeks, which explains that big jump in the observing window I talked about earlier. Activity in the sun's southern hemisphere over the past month, especially from active region 3762 that has just rotated out of view around the sun's eastern limb. Adjacent active regions have interconnected magnetic field lines, so an outburst of flares in one can trigger an outburst in another. Last week alone, there were over 14 strong M-class flares and one X-class as 3762 traded punches with those other southern active regions. The activity will continue with more regions growing as they rotate to 3774 and 3780. 3774 is taking aim at us pretty much right now while growing considerably in both the number of sunspots and size. It has strong potential for C-class flares and moderate 35% chance for M-class. Even more impressive is 3780. It's a monster, 3 times as large as 3774 and still growing. Its sunspot number is also growing, and it includes what are known as delta spots, where positive and negative umbra share the same penumbra. Now that's intense. M-class at 50% probability and X at 15% already. I wonder if it will continue to grow as it rotates towards us. This chart from the NOAA Space Weather Prediction Center shows actual versus predicted sunspot counts thus far into solar cycle 25. And you'll notice that actuals have exceeded expectations since the cycle began. Statistics gathered for July show a count of 196, nearly double their prediction, and far exceeding the cycle's expected maximum next year, at least according to the NOAA. When solar cycle's maximum has actually occurred can only be determined a few months after we have passed it, because some cycles experience twin peaks, or 2 maximums a few months apart. So the count may go down and then back up again before going down and staying down, at which point we can determine when that peak happened. If you get 2 peaks, it's because one of the poles, the positive or negative, settled into its permanent position, into its home position, while the other pole is still searching for home. And that's when you can get 2 different peaks. Now on to the moon. Our moon reaches apogee on August 9 at 405,000 kilometers from Earth. When full on the 19th, it's almost at perigee, reaching 98.5% of its perigee size, making this a supermoon. Perigee is reached 2 days later on the 21st, when the moon appears 11% larger than at apogee, and new moon occurs on September 3, so we'll have dark skies on the Labor Day weekend. By the way, the full moons of August through November will all be supermoons. This coming Saturday night, 2 craters in the Explore the Moon observing program, Aristoteles and Eudoxus, lying near the terminator, are ideally illuminated for observation and can be studied together in the same field of view. Aristoteles is the older of the two and wider at 87 kilometers versus Eudoxus at 67. Both have well-defined and broad rims, nicely terraced. There is an interesting radial pattern around the northern rim of Aristoteles that you can see when the sun is at a very low angle. Neither crater sports a tall central peak. Aristoteles has an uneven rippled floor, while Eudoxus has a cluster of low hills on its floor. And if you're lucky, you can catch sunlight racing across the floor of Eudoxus, exposing those hills. And now it's time for close encounters of the moon and planetary kind over the next 4 weeks. The first, starting with the moon, setting 4.5 degrees ahead of Spica as the evening twilight darkens. On Friday, August the 9th, that's this coming Friday. And on Tuesday night, August 13, you can catch the moon only 1.5 degrees west of the red supergiant Antares, one of the largest stars known. It's 555 light years away and 10,000 times brighter than our sun. Maybe it would be possible to image the moon and Antares with globular cluster M4 positioned in between, but I'm not sure if the first quarter moon would wash out M4, but it might be worth a try. The next morning, you can watch Mars and Jupiter rising less than 0.5 degree from each other, possible to catch in the same telescope field of view, if it's a wide field eyepiece. In the evening of Tuesday, August 20, Saturn has a close encounter with the Sturgeon moon. You can catch them together in a wide field with the limb of the moon just inside the field. On Sunday night, August 25 into Monday morning, the last quarter moon rises right behind the Pleiades, making for a spectacular sight. Hopefully, the brightness of the moon does not wash out the Seven Sisters. A dry, transparent night will help. And the following morning, Tuesday, August 27, the moon, Jupiter, and Mars rise in a diamond formation with Elnath Beta Tauri, a bright 1.65 magnitude star. And on Friday morning, August 30, you can catch the moon rising in a nearly straight line with Castor and Pollux. Those are the heads of the Gemini twins. Now, I mentioned at the top that August is a good time to observe Messiers and the finest NGCs. So let's compare 2 planetary nebulae and 2 open clusters found in the finest NGC and Messier catalog observing programs to round out tonight's tour. We'll work our way from north to south, starting with Planetary Nebula NGC 6445, found in northern Sagittarius, not far from the border with Ophiuchus. It's located a little over 2 degrees northwest of 58 Ophiuchi, a magnitude 4.9 star. Now, a planetary nebula marks the death of a sun-like star as its former shell of gas drifts off into space. The ejected shell is a type of emission nebula because the exposed core of the star, hundreds of thousands of degrees hot, energizes the expanding shell, causing it to glow. Planetary nebulae are small and frequently circular in appearance, causing Herschel Walker in the 1780s to famously say they resemble planets, and the term planetary nebula was coined. Now, NGC 6445, however, appears rectangular instead of circular. Perhaps it got its nickname the Little Gem Nebula because planetary nebulae are small, and this one resembles an emerald-cut gemstone. Maybe that's the reason. For comparison, the other planetary nebula is NGC 6369 found just inside Ophiuchus. If you star hop, you can start with magnitude 3.3 theta Ophiuchi, hop a degree plus northwest to magnitude 2.7 beta, and then another degree west to that dim 4.8 star C Ophiuchi, which is half a degree west of the nebula. The planetary nebula is round and planet-shaped and relatively faint at magnitude 11.4. The high energy radiation from the central white dwarf causes the surrounding nebula to emit light from ionized oxygen, colored blue in this Hubble image. And the hydrogen looks green and nitrogen would be red. Now, the little ghost nebula's round planet-like shape is visible under strong magnification, as seen in this sketch by H.D. Curtis back in 1918 at the Lick Observatory. The nebula should be visible with strong magnification. Here we're up to 337x. And the first of two open clusters is NGC 6520, also known as the Dead Man's Chest Cluster for reasons I could not find. You can locate the cluster around 1 2/3 degrees north-northeast of 4.5 magnitude Gamma 1 Sagittarii, or just over a degree northwest of an equally bright field star to the northeast there. 6520 is superimposed upon the large Sagittarius star cloud. It is magnitude 9, has a diameter of 5.4 arc minutes, and has about 25 stars of magnitude 9 to 12 in it. And the dark nebulae Barnard 86 lies right up against its western edge. Now, under good conditions at the eyepiece, this can be an amazing sight, like a sea of milk, punctuated by the cluster's bright stars and the adjacent inky black B86. That will create a fascinating view at the eyepiece. Now, B86 is one of the coldest regions that we know of in our galaxy due to its high density, blocking out any light from entering and heating up the dust. B86 is fluctuating, kind of like jelly, and it's apparently on the verge of collapsing to produce a star or two in a couple of 100,000 years. Now, the Trumpler's classification includes R, and R means rich, 100 stars or more, so there must be more than the 24 that we talked about at magnitude 9 to 12. So many of the fainter stars in this neighborhood are probably member stars of the cluster. And our final object, our comparison star cluster, is M7, also known as Ptolemy's cluster, and NGC 6475. Excuse me. The cluster has been known since antiquity. It was first recorded by the 2nd century Greek-Roman astronomer Ptolemy, who described it as a nebula in 130 AD. It is the southernmost entry in the Messier catalog, with a declination of minus 34 degrees. Summer is the only time to catch it from up north, but for those observing from the southern hemisphere, M7 is easily observed high in the winter sky, about 13 or so degrees from the zenith. And it can be seen sometime during the night on most months of the year from the southern hemisphere. Now, you can find the cluster around 2 1/3 degrees north-northwest of G Scorpii, though the cluster is really bright enough that you can probably find it naked eye, just looking north of the Scorpion Stinger. M7 is 200 million years old, a relatively young cluster. Its members include a diverse assortment of spectral types, mainly consisting of hot, luminous, and short-lived B-type and A-type stars. However, it also hosts a number of cooler stars more like our sun, G-type and K-type stars, making this cluster a popular site for exoplanet searches. The cluster's brightest star, a K-type giant, shines with a magnitude of 5.6. The hottest is a main sequence star of spectral type B6. And those
Okay.
B stars, they only live for a couple of hundred million years, so some of those might be ready to pop. The abundance of heavy elements or metallicity in the stars of M7 is comparable to that of our sun, meaning they all form from similar material, and that also increases the interest in finding exoplanets here. The cluster is by far the brightest of the four DSOs we've looked at, shining at magnitude 3.3, glowing like a nebula to the unaided eye. And under magnification, here we're looking at it through binoculars, the cluster's concentration of stars look like crisscrossing rows of bright stars surrounded by a scattering of more of similar brightness. Again, the Trumper classification includes R, meaning 100 or more, so many dim stars towards the center may belong to that same cluster. And that's a wrap. So are there any questions?
Arnold, thank you for another detailed and well-delivered presentation. Well done.
Thank you.
Let's go to Ennio. Do we have any questions for Arnold?
We have a couple of questions. First, a comment from Leo to CAF, who says, spotted Neptune last weekend of July. This prompted Betty to ask the question, would Neptune be easy to see with binoculars or is a telescope necessary?
You know, at magnitude 7 something, it should be just as easy to spot either way, I would imagine. It's not like you're going to see any detail with a telescope. Although you might gather more light, it might be a little bit brighter. I'm not sure, but it should be visible either way.
Okay. Eric asks, please, what Starry Night Horizon panorama is that with the row of cars?
I'm afraid I didn't understand. Can you repeat, please?
So in Starry Night, you have a horizon with a panorama with a row of cars.
Oh, yes, that's right. It's one of the Starry Night choices from the landscape scene. I don't remember which one off the top of my head, but if you're playing around with Stellarium, you can definitely. It's one of the top 4, I believe.
Okay, and this just in from Ron McNaughton. Just before the meeting, I got an email that there was a G2 class flare with possible arrival on August 9th. How strong is that? And great talk.
Thank you. G2 flare. I'm familiar with the C, M, and X. I don't know what a G class might be. I'm afraid I'm unable to answer that question.
Fair enough. That's all the questions we have.
Okay, well, thank you. In fact, I'll try and look up what a G class flare. If I can find any information, I can post it on our forum for those that want to check it out.
Okay, yes, please do.
Okay.
All right, thanks again, Arnold.